Hello. Linda Akofala. Linda and Akofala, can you hear me?
Yes, please.
Okay. All right. Akofala, are you there? So, Linda, you can hear me, right?
Yes, please.
Okay, I think Akofala's audio has a problem. Okay, Linda, let's wait for your people for some time, okay? In the meantime, Linda, if you have any question, you can ask. Whilst we wait for them, you can ask your question, okay? Hello, Linda. Hello, Linda.
Instead, yeah.
Are you okay with what we learned last time?
Yes, please.
Hey.
Yes, please.
Okay. All right, then that's good. Today we are going to solve one or two questions and then continue, right? So we have Carol. Hey, Carol. Elisa.
Yeah.
Hey, at long last. You are here finally. So I have Eliza, I have Mirabel, I have Carol. Welcome. I mean, all of you.
Thank you.
Okay. All right. I think we have 1, 2, 3, 4, 5 for now. The rest you have to join. Carol, Eliza. We started vectors. And
Yes, please.
And you have to see your colleagues for updates on where we got to last time. Okay. Whilst we wait for your friends, let's tease our brains a little bit with 1 or 2 questions. It isn't a brain twerking question. Hey, Mirabel, it's not a brain twerking question, okay?
Okay.
Okay, so if you have 2 forces acting on a body. Hey, I think I have to change marker. Okay, I'm coming. There's supposed to be a new marker. Eliza. So we have these 2 forces acting on this mass. In one breath, I hope you can see clearly from the board.
Yes, please.
So in question 1, we have 5 Newton, 2 Newton. The 2 forces are acting along the same plane, the horizontal plane. In question 2, we have 6 and 8 Newton in this direction. And then we have 12 Newton in the opposite direction. Then in the third situation, we have one in this direction, then we have two. The magnitude of this is 80 Newton, then 40 and 100 Newton. So we have 1, 2, and 3. The question is that find the resultant force. We have to find the resultant force in the 3 instances. So Mirabel, I'm starting from you. Help me determine the resultant force in question 1. So,
please, I can't see the one at the number over here.
which
Yeah, I
one?
can't see. Sorry.
Is it 2?
The first one, I can't see the number.
This is 12. This is 12 Newton. Okay. We have to find the magnitude, the resultant force, and the direction. So it's a 2-in-1 question. Find the resultant force and the direction. Hello.
I didn't hear what you said.
Variable. I'm saying that we have 12 Newton acting, okay, at my left, 5 Newton acting at my right. You have to find the resultant force and the direction of the resultant force. And yours is the question 1.
Okay, so I think it
yours
will
is
be
question
7 newtons.
There is the resultant will be 7 Newton.
Yes, please.
To which direction?
To be to your left.
To the direction of what? Is it the 12 Newton or the 5 Newton?
The 12 Newton. The 12 Newton.
So the resultant is simply the difference between them. For A minus B, and here it is the bigger minus the smaller. Or we are assuming A is greater than B, and so R will be equal to 12 minus 5, which is 7 Newton, and that will be in the direction of the larger force. Please, are we fine? If you want to use,
yes,
if you want to use almighty cosine rule, then this is how it will also be. R squared is equal to F1 squared plus F2 squared minus 2F1 F2 cos of 180 minus theta. Now F1 is 12. F2 is 5 minus 2 times 12 by 5 times the cosine of 180 minus, please, when the two forces are acting oppositely, what is the angle between them? What is the angle between them? What's the angle between the forces here?
yeah.
180 degrees.
So the angle between them is 180 degrees. So if 180, then we have cos 180 minus 180. Therefore, 144 plus 25 minus 2 by 12 by 5. What is this? Is cos 0. And what is cos 0? Cos 0 is equal to what? Cos 0 is equal to
1.
Cos 0 is equal to 1. Cos 90 is 0, and so cos 0 will be 1. So we have 169 minus 2 times 12 times 5. We have 120. 120. Subtract 120 from 169.
What is it? How are we subtracting the 180 from the 180?
Pardon?
Sandra, please, over here, why are we subtracting 180 from 180?
Theta. From the cosine, this is the cosine rule. 180 minus theta. And theta is the angle between the forces. Here, the forces are like this. Okay, one in this direction, one in the other direction. So the angle between them, theta, is 180. So that's why we subtracted 180 from 180. Are you okay?
Yes, please.
Okay, so we have 49. When you subtract 120 from 169, it is equal to 49. Therefore, R is equal to the square root of 49, which is equal to 7 Newton. Same as what we got. Is that okay? Confirming what we learned yesterday. Okay, Linda, question 2 is for you. Linda, question 2 is for you. We are to determine the resultant, the magnitude of the resultant, and the direction. Linda, we are waiting for you. What do you think will be the magnitude of the resultant force here? Linda, if you don't have any idea, let's continue. Eliza, can you help us?
Yes, please.
Okay, let's go.
Please, the resultant is 12 Newton.
How did you get that?
Please, I added the 6 Newton to the 8 Newton. I subtracted 2 Newton from it.
Eliza, you are missing something. Christabel, any idea?
No, please.
Okay, Carol. Question 2, Carol. Okay, time sake, let me take over. You see, here, look at these two. Okay, unlike in the first situation, we had one force here and another one here. So single forces in both directions. Here we have two forces in one direction and a single force in the opposite direction. So what you do is that you sum up all the forces in one direction. So if they are 100, F1, F2, F3, up to 100. Then when you finish, you subtract the least one from the larger one. So because 6 and 8 are in one direction, we will sum them up. 6 plus 8 in one direction. Then minus 12 Newton. The reason why we are subtracting the 12 Newton one from this is that the sum up forces is greater than the left-hand side. So this will give us 14. 14 is greater than 12. So to find the resultant, we are subtracting the smaller one from the larger force. If it had been that when we added, these two are less than this one, we would have subtracted them from the 12 Newton. Please, are you okay? So we have 14 minus 12, giving us 2 Newton. So that's the resultant. The direction of the resultant is in the direction of the two larger forces, which is to the right. Please, are we fine?
Yes, please.
Yes, please.
Okay. Then, Carol, the third one is for you. What is the resultant? The resultant, and then the magnitude of the resultant. Before Carol comes in, let's also apply a different method. So what it means is that in actual fact, the forces to my right, okay, must be 14 Newton. So let's represent it by a single vector, and this is 14. Once it is 14, let's take this to be F1. Let's take this to be F2. And what's the angle between them? What's the angle between them?
180.
180.
180 degree. Good. So if you use Pythagoras theorem, F1 squared. So F1 14 squared, I said Pythagoras cosine rule, plus 12 squared minus 2 by 14 by 12 times cos of 0, because it will be 180 minus 180. So 4, what is 14 squared? What is
196.
Pardon?
196.
Plus 144 by this is 24 by 14. Multiply 24 by 14 for me. Cos 0 is 1. So 24 by 14. Zero.
236.
200 and what?
336.
Okay. 0. This is 4, 3. So we have 3, 4, 0 minus 3, 3, 6. Okay. And when you subtract, this is equal to what? What is 340 minus 3? This is 4. So R is equal to 2 Newton. Just same as what we got. Are you okay? And the direction of the resultant will be the direction of the larger. Okay, Carol, your question.
Instead, we apply the method we used in the second one.
So give me the answer.
This is 40 and what? 1?
40 and 100.
Okay. So we sum the 40 and the 100.
Okay.
To get 140 Newton.
Okay.
Which is greater than the other side.
Exactly.
Let's say
so 140 minus
Newton
80. Okay.
60 Newton.
And that will be 60 Newton. So what's the direction of the resultant? The direction is to the what?
The direction will be
downwards.
It will be in the direction of the yes.
Downwards.
Yes, please.
Let's use the other one. The other cosine rule 2.
The cosine.
140. Please use the cosine rule to confirm. And what's the angle between them? 180.
180.
Exactly. So
Mr. Dia,
hello.
please, in using the cosine rule to confirm, F1 and F2 is 60
So
squared, or 140 squared and 30 squared.
Yeah, F1 is 80, F2 is 140.
Okay, thank you.
Welcome. All right, so as are you there?
Yes, please.
Okay. Another one, then I increase the level of the difficulty. So we have this other one. Mirabel, you can't see it.
Oh, I can see now. Thank you.
Okay. Now, the mass of this is 100. Okay, that means 10,000 grams. I'm adding something to the question. Then this one, I'm sure you are true with the confirmation. You are only confirming this. Are you true? Yes. Yes, you are true. So the question is that determine the resultant force and the direction. The direction. And the direction and you are also to determine the acceleration. Calculate the acceleration of the body. This is 10 kilograms. Okay, let me 0.2 kilogram. So I want you to determine the resultant force in question 1 and 2. Then I come in with the resultant and the direction. Then I take you through how to determine the acceleration. Is that okay? For both 1 and 2.
Yes, please.
Stage, please come to the school.
Come in.
Can't see now.
I couldn't hear you out. Nana, everybody, you are welcome.
Mr. Dia, I was here quite some time ago, but thank you.
Yes, but where is Nana Jimfua?
She's here.
Mr. Dia, please, I'm here.
The late Nana Jimfua. Okay, welcome to.
Thank you.
Three minutes more.
Stage, please, I'm not done copying the question now.
You are not done copying the question.
Yes, I have switched off your video.
No, I haven't switched it off. It's still on. Are you through? Mirabel. Mirabel. Okay. Let's look at it. Please, if you have a problem with the video, try and then reconnect. I think it's a network problem. Okay. Try and then rejoin. Okay, so let's Whilst we go through, I think you use that to look at what you were able to produce. So we have 3 forces in this direction. Okay, so summation of them, summation of the forces here, since they are all in one direction, we sum them up. So 25 plus 45 plus another 27. This will give us, please, when we sum up all the forces, what did you get for? The forces at the right hand side. So summation of the forces at the right hand side, then at the left hand side. What did you get for this side? 70 plus 27. So this is 97. Okay. 38 plus 88. So 126. Okay, so 97 Newton as against 126. Therefore, the resultant will be equal to 126 minus 97. And that is equal to
29.
That's equal to what? 29. Okay, so the direction of the resultant will be to the left. Okay, it will be to the left. Now, the second question. Calculate the acceleration of the body. Please, whenever you calculate the total forces, okay, on a body, and it is equal to 0, then it means that the net force on the body is equal to 0. When the net force is equal to 0, the body is said to be in equilibrium. When the net force acting on a body is equal to 0, the body is said to be in equilibrium. Is that okay? Now,
yes,
when the body is in equilibrium, it does not accelerate. It does not move. Its velocity doesn't change. Okay. Here, when we calculated, the net force or the resultant force is not equal to 0. Carol, are you asking a question?
no, please.
Okay. So when we calculated, the net force is not equal to 0. Once it is not equal to 0, then it means the body would accelerate. Okay, the body accelerates only when the net force or the resultant force is not equal to 0. Okay, so we've got a resultant force of 29. And from Newton's second law, force is equal to mass times acceleration. Here it means any force, it can be a net force, it can be a resultant force, it can be an unbalanced force. Any force is equal to the mass times acceleration. So once we have a resultant force, which is also a force, then we equate that to 29 is equal to the mass of the body. But what is the mass of the body? 10,000 grams. We have to change the mass of 10,000 grams to kilogram. Eliza, do that for us. Convert a mass of 10,000 grams to kilogram for us.
It's 10 kilograms.
Pardon?
10 kilograms.
Good. So this is equal to 10 kilograms. 10. Please, when you leave your mass in gram to calculate, you are wrong because this force is in Newton. Okay, because the force is in SI units, the mass must also be in SI units. So times A. Therefore, A is equal to 29 over 10, which is equal to 2.9 meter per second squared. So this is the acceleration of the body, meaning that when the resultant force of 29 Newton acts on the body would accelerate speed by a magnitude of 2.9 meter per second squared. So that's the answer. Let me see by hand those of you who got it right. If you got everything correct, let me see you. Oh, okay. All right. Then okay, you've done well. This is a feather in your cap. Hey, Carol. All right. Question 2. Let's look at question 2. The same thing. So you sum all the forces up in one direction. 75, 95, and 250. 0, 5. Okay. This is 8, 17, 19. All right. So we have, please, are you there? Hey, hold on. Go. 75, 95. Go ahead. So we have 0. Ahead. This is 8, 17, 22. Are we there?
Yes, please.
Okay, so the next or the resultant force is equal to 420 minus 325. And what is 420 minus 235?
95.
Pardon?
95.
So 95. And so it means that the direction of the resultant will be downwards. Because when you sum up this, is greater than the upward one. And once there is a resultant force, it means the body will accelerate. Okay. Once there is a resultant force, the body accelerates. Now, we are calculate the acceleration for us. Calculate the acceleration for us.
Mr. Dia,
Yes.
the second one, the one with the 0.2 kg.
Come again. 0.2, yes. The mass is 0.2 kilogram.
That one I got 475.
As acceleration.
Yeah.
Let's have a second now. What did you also get as an acceleration?
Please, I got 475.
Okay, Lena, you got the same. So A is equal to 95 over 0.2. Okay, so we have 95 over 2 on 10. 95 on 1 times 10 on 2. This is 5. So 95 by